Welcome to EDU World Space.
So we want the mass on the cube and the buoyant force of the cube. So we can say that mg, the weight, would be equal to the buoyant force of the oil plus the buoyant force of the water. And this would be equal to the density of the oil times the volume of the oil times gravity plus the density of the water times the volume of the water times gravity. And we can say that mg will then equal the density of oil times L squared times 0.28 L times G plus the density of water times L squared times 0.72 L times G. G's are going to cancel out. And we find that the mass is simply going to be equal to L cubed times 0.28 times the density of oil plus 0.72 times the density of water. And so this is going to be equal to 0.1 meter cubed, and then the density of oil would be 810 kilograms per cubic meter, and then it'll be plus 0.72 times 10 to the third. So the density of water would be 1,000 kilograms per cubic meter, and the density of oil would be 810 kilograms per cubic meter. And we find that the mass is going to be 0.947 kilograms. So this would be the first answer, and then the second answer, they want the buoyant force. So the buoyant force would simply be equal to the mass times the gravity, because this is in translational equilibrium. So this would be equal to 0.947 times 9.8, and we find that the buoyant force is going to be equal to 9.3 newtons. My apologies, approximately 93 newtons. I'm sorry, I'm reading that wrong. 0.947 times 9.8, a bit less than 9.8. My apologies, 9.3. I thought that was 10 for some reason. So the mass would be 0.947 kilograms, and that would be, we would be able to find that by taking the sum of the forces in the y direction and equating the sum of the buoyant force to the weight of the object, of the liquids. To find the buoyant force, it would simply be equal to the mass times the gravity, and this is what we use to, of course, find the mass in the first place. That is the end of the solution. Thank you for watching.